Hello, my fellow YouTubers. This is Roy back again. We'll bring you through a couple demonstrations. First, let's check the poles on here. Keep this thing out of the way. There it goes. It's a magnet with an impeller. So these are Ed's magnets. They're a South Pole. Wow, the aluminum and the copper. Screwing them up. Let me see what's going on here. I like when I see crazy stuff. So there's north, South Pole, north, south, south. Something going on. Ooh, something going on. And something going on. Well, maybe I should turn down the AC out of the wall. That's what's going on. It's moving so fast. So let's put the aluminum back on. What am I making here is a beautiful linear motor. Let's go ahead and put this magnet on top of it. You can see it starts to take motion. One thing I want to tell you guys is pretty interesting. I didn't really realize or even know, but realize is that AC coming out, you're saying it's a negative and positive flipping, right? But when it comes into a wire, such as I got this spun northwise, like clockwise. You can see it comes in clockwise. So it's going to make a north there. And then I got this counterclockwise, so it's going to make a south. So every time this is switching its poles, it's switching these poles as north-south as well. Cool stuff, huh? Way cool. Look at that. We're going to get into a little levitation through magnetism to non-magnetic materials. Well, I got something even better to show you guys. Electromagnetic turning that. It's crazy. Let's go over here. So I got some two leads coming off my, this is a resistance wire. So I have a lot of people out there asking me, why is resistance so important? Well, if I could say anything, is that if you wanted a difference in potential, the resistance would have to be different. Just think about what I just said. It would have to be different. So we have, each one of these legs is 5 ohms. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75 ohms. It's a lot. That's a lot of ohms. So what the heck do we do with this? All right. Leads are coming out, and it goes to 2 rods in the ground, which is just earth ground. Resistance to earth ground. So what will happen between those 2 poles? Those 2 rods go down about 2 feet each in the ground. Think about that. The composition is concrete and then sand and dirt underneath it. So what is dirt? What is sand? That's another important thing about composition of materials or elements. So coming out of each one of those, I got it running to this 12-volt battery. Okay? 2 resistance, 2 poles coming off my resistance wire. Why resistance? Let's look at this. Let's turn on the voltmeter. Now the voltmeter, when I turn it on, is DC, and we're talking this battery here. Now this battery, I turned it on, and you can see it's at 13.94, 13.94 0.95. So what I did was I charged this battery to 13 the other day. And I connected it this way, and I could see a charge increase, 13.95. Pretty interesting stuff. Increase. There it goes. Look, it's going up to 6, 7. Look, it's climbing up. Should we just wait a minute? So it's climbing up. Climbing up. We're watching it climb up. 13.96 to 7. So we just went from 6 to 7. So it's climbing. Why is it climbing? Why is resistance important? Leave your comments. Leave your comments, because these are things that I've been studying, and guess what? I want to let you know. You just have to ask. 13.97. Let's see if it climbs up anymore. And then we're going to do another demonstration. We're going to run, this is a 24 volt motor DC. That's a 12 volt motor DC. Wait, whoa, hold on. 13.97. Ooh, wait a minute. Do I see a little inclination of going up? 13.98. Can I get a 13.98? Come on now. I feel like one of those barkers at a auction. Whoa, it's going up. All right. So let's talk logistics here. Battery has a certain pressure. In order to have 13 volts, which is a 12 volt battery, right? 12 volt battery. Let's look at the battery. The battery's a 12 volt battery, and it's a 7.2 amp hour. All right, that's the size. That's the battery. And we're increasing our voltage, so we're still charging it. I mean, the same if I had the charger over here. This is crazy. This is how I charged it originally. It's my little charger, not connected to nothing. And great charger, but I brought it to 13 volts. And I said, well, let me go ahead and connect some resistance into 2 poles in the ground. And so the ground is giving up a little something something for Mr. St. Vinny. Oh, whoa, 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 whoa. Do I see a little inclination? Hold on. Whoa, 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 whoa. Whoa, 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 whoa. What's that? What did I just say? What did I just say? It's climbing up. See, it's supposed to. This is supposed to happen for me to show you. Wait a minute. Can we get it to 14 volts? All just by itself? So what do you think? Leave your comments. What do you think if we put a load on it? What's going to happen? If you're smart like me, you would say the voltage will start dropping. Based on how much current you put on it, it should drop quite fast. Correct? All right, let's go ahead and put a load on it. So we're going to put the 24 volt. Forget about the 12 volt. I'm just going straight in. It's already connected. I just got to hook up one wire to it. Let's go ahead and hook up the 24 volt. Whoa, wait a minute. Whoa, before I do anything, we jumped up to 14. Look at this, guys. All right, wait, well, hold on. This is pink. This is yeah. I'm just going to absorb this right now, because this is happening in front of your eyeballs, right in front of your eyes. It's just climbing. So we're adding more electrons in there. Where are the electrons coming from, guys? From them two rods. Now remember, one rod here, there's a little copper on it. And the other one doesn't. The other one's just iron. Not going to give you everything. I'm just going to tell you the elements matter. We're up to 14. Yep. Let's put a load on it. It's going to drop. Hold on. I want to put you guys on my tripod so I can go pee while we check and see how much it drops. Tripod. Yeehaw. I would just say count the time. Now look at that voltage going up. Let me get to a better view. So we got the battery, the resistance, and now a load, and it's climbing. Yeah, my garage brohams. What do you want to call this? Running a DC 24 volt motor. Volts is up to 14. 12 volt battery. And I'm just letting you see it run. So how come it's not dropping, guys? Leave your comments. Peace out, my brohams. Peace out.